So starting your review summary for the course, you've got a blank piece of 11 by 17 paper folded into thirds. The first page is just going to be put a title on it or something. So I'm just going to write chemistry exam review on mine, but you can do what you like. You might want a few different colors for this. I'm going to be using blue and red for mine, as well as having like a purple and yellow highlighter. So chemistry exam review. Awesome. All right, first unit, we're just going to look at the first panel. So just on the inside cover, I'm going to fold it around just to make it easier to write on. And we're going to start by adding a title at the top. So unit number 1 was our chemical reactions unit. Underline that. It's really important that you don't lose this piece of paper because we're going to add to it each class. Okay, so the first thing that we did was a little bit of naming practice. So we're going to quickly summarize a few of the naming rules. So naming is going to be our first sort of subtitle. We'll start with ionic compounds. So ionic compounds contain a metal and a nonmetal. So we name the metal first, and then we add the name of the nonmetal and we change the ending of the nonmetal to "-ide". So plus the name of the nonmetal. Add the IDE on the end. So for example, MgCl2 would be magnesium, so we name the name of the metal normally. Chloride. So instead of writing chlorine on the end, we change it to chloride with that "-ide" ending. The next piece is looking at multivalent metals. A multivalent metal is a metal that has more than one stable ion charge, so that's things like copper and iron and lead. And we have to add the Roman numerals. So we add Roman numerals after the name of the metal to indicate what charge your metal has. So for example, CuCl2 would be copper, but copper can be copper 1 or copper 2. In this case, it's copper 2. So we put brackets and we put 2 in the brackets, and then we give the name of the nonmetal ending in "-ide". Next bit that we can add to this is our polyatomic ions. And when we name compounds, ionic compounds with polyatomic ions, it's just the name of the metal plus the name of the polyatomic ion. We don't change anything about the second part of the name. We don't end it in "-ide" or anything weird like that. We just write exactly the name of the polyatomic ion. So name the metal, and then the name of the polyatomic. So for example, if I have something like AlNO33, that would be aluminum, so the name of the metal, nitrate, name of the polyatomic ion. Next, we have molecular compounds. Molecular compounds contain only nonmetals. And they have slightly different rules. So rather than showing a ratio of metal to nonmetal, a molecular compound contains an exact number of atoms in the compound. And so we use the Greek prefixes to indicate how many of each atom type there is. So for example, N2O5 would be dinitrogen, because di is the prefix for 2. Pentoxide, because penta, and you could put pentaoxide or you can just make it pentoxide, doesn't matter. That's the prefix for 5. Next thing, we have our diatomic gases. So our diatomic gases is the Hofbrinkel group, which means that they come in pairs. So that's Hofbrinkel, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. And so an example for that would be like H2 is just hydrogen. Next we have acids. So acids have a couple different types. So anytime you have an acid that's made with a polyatomic ion, it ends in ic. So you change the ending to ic and then you have the word acid on the end. So an example would be like nitric acid would be nitrate with hydrogen added to it. Or we can also have binary acids, which means binary, bi means 2. Binary acids are things like HCl. And all we do is we add the word hydro in front of the ic acid name. That tells us that it's a binary acid and not an oxo acid. So that would be things like hydrochloric acid or hydrofluoric acid. Then we have bases, which are named exactly the same way as regular ionic compounds. So magnesium hydroxide or sodium hydroxide or lithium hydroxide, etc. Oh. Ionic compounds. So this is just a really brief overview of all of the different naming rules. If any of these are sort of making you feel like you don't know what I'm talking about in the examples, or you're looking at one of these rules and you're like, I don't really know how to do that, then go back to your notes on that piece and do some practice and work on it, because this is just a very brief outline to sort of jog your memory and remind you about all those things. So the next thing is just writing formulas. So naming, and then we've got formula writing. This is just going to be a really short note. With formulas, with ionic, it's a ratio. So we want it in lowest terms, and we use the crisscross rule. So for an example on the end here, if I have magnesium 2+, and then Cl is 1-, I crisscross, and that's what gives me my Mg. There's an imaginary 1 there, Cl2. With ionic compounds, there's no, or with, molecular compounds, there's no crisscross. So molecular, do not crisscross, because it's an exact number, not a ratio. Then we did some balancing reaction equation stuff. So balancing chemical reactions. And the key to balancing is that you just need the same number of each atom type on both sides of the arrow. So need the same number of each element on both sides of the arrow. If you need extra balancing practice, I have some from the beginning of the year. Hopefully you guys are feeling pretty comfortable with that at this point in the year. Next we did types of reactions. And there are 5 types of reactions that we talked about. So the first one is synthesis. So a synthesis reaction is when you have more than one reactant and they come together to make one product. So recognizing synthesis reactions have one product. Next is decomposition, which is the reverse, where you only have one reactant, which breaks apart into multiple products. So these are just the general equations to give you an idea. You will need to be able to predict products on your exam. Next we have combustion reactions. Combustion reactions are when you have a reaction with oxygen gas to form some kind of oxide as a product. So they can be reactions that are also synthesis reactions where you have a metal and oxygen forming a metal oxide. But you can also have combustion reactions where you have hydrocarbons reacting with oxygen gas. So something that's made of carbon and hydrogen, so the X and Y just represent some unknown numbers, plus oxygen gas. And the products of these types of reactions are always water and carbon dioxide. So then we've got single displacement reactions. Single displacement is when you have one element by itself reacting with a compound, and the metal that's on its own will swap places with the metal that is in the compound, or if the thing that's on its own is a non-metal, it'll switch places with the non-metal to form a new thing by itself and a new compound. And so for these, you need to remember your metal activity series, which is on the back of your periodic table. And for the non-metal activity series, remember that it's just in the order that they appear on the periodic table in the halogens. So fluorine is the most reactive, and then down from there is less reactive in that row. The last one is double displacement reactions. Double displacement reactions have 2 compounds reacting together, and the 2 cations will switch places so that we form 2 new compounds at the end. And for these types of reactions, you need to remember to check your solubility rules to see if you have a precipitate forming.